this, as we are also one of the participants in SIH. Our team name is Transportrix. So we made a solution on the problem statement maximizing section throughput using AI power precise train traffic control. So we are developed for this both backend and frontend. So in backend we used Python code. So let me run this. So to run the backend code, we have to enter type Python space app.py and enter. So let me open this URL to check whether it is running correctly or not. So yeah, it is displaying the train control backend running, use frontend to interact. So there is no problem with the backend. Now let's get into frontend. Here frontend, we are used HTML, CSS and JavaScript, and we combined in one file named it as index.html. And let me show you the output. So yeah, this entire framework is made with the Flask, and these are dashboards like control panel, system metrics, calculate the systems, event log, updates the schedules, updates the details, and train schedule, updates the schedule, start time, end time, and trains. So when we click on the initialize network, from the backend it notifies that network initialized, and when we click on the load conflict scenario, it is same again displaying that conflict scenario loaded. That means multiple trains want to access the same section at the same time. So when we finally click on the run simulation, simulation started, simulation clock begins, and trains are scheduled for the starting time and end time. And the first express got scheduled in the section 1 for the starting time 9:30, and it is entered Bangalore city, and it is showing the status yellow, and it got delayed by 5 minutes, and it is showing the status red. Due to the conflict at section 1, another train is planned, and AI allowed express to continue but with delay. And it got train exited Bangarapet at 9:45, and it's showing the status green. And finally train exited Jolarpetai at 9:45, and it is showing the status green. Now finally Express 001 completed section 1 with 5 minutes delay. Then freight scheduled for section 2 with the start time of 9:40 entered Bangarapet. AI allowed it move since Express had already cleared section 1, so there is no delay for the freight, that is means goods train. And now passenger got scheduled for the section 2 at 9:50, and it entered Bangarapet at 9:50, and it is showing the status yellow, and it got delayed by 4 minutes, and it is showing the status red. And it exited from Jolarpetai at 10:03, and it is showing the status green. And exited from Katpadi at 10:03, it is showing the status green because there are no trains in the section. Finally it exited Arakonam at 22, same 10 minutes 3 seconds. So finally passenger also exited from Arakonam at 10:03, and it is showing the status green. So now let me show you the live map, train live map. So here it is. Each train station has a geolocation marker. As simulation runs, markers positions update to reflect current location, helpful to visually confirm where congestion zones are occurring, and it measures the accurate position of the trains. That I can show here that Express 1 train exited Jolarpetai, and this is freight which is exited Katpadi, and passenger 001 it is exited from Arakonam. And finally one last dashboard is system metrics, where the performance numbers updated in real time, throughput, the number of trains are passed through a particular section, average delay, means delay across completed trains. Total trains are 3 and total sections are 2, that is section 1 and section 2. Now let's go with the quick summary of outcomes. Express 1 got delayed for 5 minutes and freight got delayed for 0 minutes, and there is no delay for freight, so and the passenger got delayed for 4 minutes. Overall, all trains reached destinations. Average delay acceptable at 3 minutes. So this is how AI conflict resolution worked. It detected the conflict between express and freight overlap and slowed down the express instead of stopping freight. Whereas in the real world, it goes with a priority order. It doesn't slow down the express. It allows the express and it delays the freight train. By delaying the freight train, the trains which are scheduled after some time got more delayed, and therefore the delay time will increase and the throughput will decrease. So but in this scenario, it goes with a priority order: express greater than freight greater than passenger. So in this way, the AI is helpful to reduce the time delay and increase the throughput. So yeah, this is our prototype for the given problem statement. So this is our prototype. Thank you.